Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one of the gate question which came in the year 2011 related to preemptive shortest job first scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me discuss the question, then I will provide the solution with you. Look at the question. Consider the following table of arrival time and burst time of three processes P0, P1, P2. They have given the arrival time and burst time with respect to the milliseconds. The preemptive shortest job first scheduling algorithm is used and then find the average waiting time to execute these three processes. They have given four options. We need to solve the question and find out what is the right answer. If you look at the scheduling algorithm, they have mentioned as preemptive shortest job first scheduling algorithm. Preemptive shortest job first scheduling algorithm is equal to shortest remaining time scheduling algorithm. Is it clear? To confuse you, they have mentioned as preemptive shortest job first scheduling algorithm. Okay, now let me solve this question. To solve any scheduling algorithm, we need to draw the Gantt chart. Let me draw the Gantt chart for you. Always the Gantt chart will start from 0 units of time. Okay, here the units of time mentioned in milliseconds. Okay, at 0 milliseconds, what are the process have been arrived the ready state we need to look at. Okay, look at the arrival time of all the three processes. Process P0 has arrived at 0 milliseconds. Process P1 has arrived at 1 millisecond. Process P2 has arrived at 2 milliseconds. So at 0 milliseconds, only process P0 is arrived. If only one process has been arrived, we will dispatch this process P0 to running state. Okay. Now P0 need 9 milliseconds or 9 units of time to complete its task. Okay. So we will run the P0 for 1 unit. Okay, and then we will see any other process has been arrived or not, because it is a preemptive. Okay, if it is not a non-preemptive, we will execute this complete process and then send it to the terminated state. But whereas here it is preemptive shortest job first scheduling algorithm, so we need to look at any other process has arrived at 1 milliseconds. Look at the 1 millisecond. P1 is arrived. Okay, and what is its burst time? 4 milliseconds. What is the remaining burst time of P0? 8 milliseconds, because out of 9 milliseconds we have executed the process P0 for 1 millisecond. So remaining burst time is 8 milliseconds and this process is 4 milliseconds. As it is shortest job first scheduling algorithm, the criteria is burst time. So the process which is having the less burst time will given high priority to dispatch to the running state. Look at the process which is there in the running state, which is P0. It requires 8 milliseconds and the process which is there in the ready state needs only 4 milliseconds. So this is having the high priority as compared to the process which is there in the running state. So we need to do the context switching. So process P0 will be shifted to the ready state and process P1 will be dispatched to the running state. Okay, now it will be executed for 1 millisecond, then its remaining burst time is 3 milliseconds. By that time, if you look at process P2 has arrived the ready state. Look at the burst time. Process P2 needs 8 milliseconds. Process P0 needs 8 milliseconds. Process P2 needs 9 milliseconds. Process P0 needs 8 milliseconds. Process P1 remaining burst time is 3 milliseconds. If you compare the process which are there in the ready state and running state, the process which is there in the running state needs less burst time. So we no need to do the context switching. We can execute the process P1 for another 1 millisecond. Then its remaining burst time is 2 milliseconds. If its remaining burst time is 2 milliseconds, again it will have the high priority because this process having the less burst time as compared to the process which are there in the ready state. So I can execute it for another 2 milliseconds. Okay, so at 5 milliseconds it will complete its task. See, I can write it as P1 1 unit, then again P1 1 unit, but still it will only have the less burst time. So I am executing it for 2 milliseconds, and once it executes its entire services, then it will go to the terminated state. So process P1 is completed its task. Now look at the process which are there in the ready state. P0 is there and P2 is there, which is having the less burst time, P0. So P0 will be dispatched to the running state. Okay, you can run the P0 for 1 unit of time, then it will have 7 milliseconds burst time. Still process P2 has 9 milliseconds. So still process P0 has the less burst time. So we can run this P0 for 7 units of time. So at 13 milliseconds, the process P0 will complete its task and go to the terminated state. Then only one process which is there in the ready state will be dispatched to the running state, and it will be executed for 9 milliseconds. Okay, process P2 will execute from 13 milliseconds to 22 milliseconds. At 22 milliseconds, all the three processes have been completed performing their tasks. Now we will compute the completion time, turnaround time, waiting time, then we will compute the average waiting time, because they have asked us to compute the average waiting time. Let me compute the completion time. What is my completion time? At what time the process has completed its all the tasks. Look at the process P0. It completed its task at 13 milliseconds. Process P1 completed at 5. Process P2 at 22 milliseconds. Now we need to compute the turnaround time. Turnaround time is completion time minus arrival time. Look at the completion time and arrival time of each process. 13 milliseconds minus 0. You will get 13. Let me make it common. It is milliseconds only. 5 minus 1, 4. 22 minus 2, 20 milliseconds. Now we need to compute the waiting time. How can we compute the waiting time? Waiting time is equal to turnaround time minus burst time. Okay, 13 minus 9 is 4. 4 minus 4 is 0. 20 minus 9 is 11. Okay, now what they're asking, find the average waiting time. How can we find the average waiting time? Average waiting time is equal to sum of all the process waiting time by number of process. So which is 4 plus 0 plus 11 by 3, which is equal to 15 by 3 is equal to 5 milliseconds. So average waiting time is 5 milliseconds. Look at the option A. They have given as 5.0 milliseconds, whereas option B, option C, option D is wrong. So for this question, the right answer is option A. I hope you have understood how I solve this question. This is very simple question. If you know the preemptive shortest job first scheduling algorithm, you can easily solve this question. If you still have any doubts related to this question or related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.